Hey Chem Kids, Campbell here. In our fourth video on Chapter 5, we're going to talk about what valence electrons are. We're going to talk about electron dot structures and how you write electron configurations for ions. Now, valence electrons are the electrons that are in that outermost energy level, at the very highest energy level. And we can represent valence electrons through what's called an electron dot structure. It's called Lewis structure also. What that means is if an atom has one valence electron, then it has a dot of 1. So a good example of that is sodium. If we wrote the electron configuration for sodium, we would have 1s2, 2s2, 2p6, 3s1. So this here is its valence electron. There's only one, so when we write its electron dot structure, we write the symbol for sodium, Na, and we put one dot by it. Another example would be magnesium. Magnesium, which is in column 2 there in the periodic table, if we wrote its electron configuration, we'd have 1s2, 2s2, 2p6, 3s2. So it has 2 valence electrons in the third energy level, and to represent it in a dot structure, we just put 2 dots. Not bad, huh? Now, we can do that for all of our atoms. Here's the S block atoms, which is column 1 and 2. And here are our P block atoms, which is the column 3A, 4A through 8A. Now, hydrogen, right, is in column 1. It has 1 dot. So would lithium, sodium, or anything else in that column. The second column, which has beryllium at the top of it, would have 2 dots. And notice that the dots correspond to the number at the top. That's true for all of these block A elements. So in column 3A, not the transition elements, notice those are kind of cut out of this map here. We have 3 dots for boron, which means aluminum would have 3 dots. Carbon has 4, nitrogen has 5, everything in this column has 6. In column 7, now ignore the fact that hydrogen is sitting up here, but column 7 with fluorine and chlorine, they would have 7. And in our very last column, which we call column 8, with the exception of helium, they all have 8 dots. So they have 2 dots on each side, and they're totally full. Now helium can't have 8 because its periodic atomic number is 2, right? Which means its number of protons and the number of electrons in a neutral atom would be 2. So, sorry, no 8 for you. So let's take a look. Find these on the periodic table and then draw an electron dot structure for them. Pause the video, see if you get it right. Well, if you gave cesium 1 dot because it's in column 1, you're correct. Aluminum, 3 dots. And bromine, 7 dots. Now notice when I draw my dots, I don't pair them up right away. Remember, that's the Hund's rule, where you don't pair up. It's the empty bus seat rule. Don't pair them up until you start having too many. So once you've reached 4 sides, then you start to pair up your electrons. All right, I have one more thing to talk about, and that's drawing or writing electron configurations for ions. So if you remember back to our last unit, we talked about how atoms form ions. It's by gaining or losing electrons. And remember I said cations are positive, and what's happening is cations are losing their valence electrons. So when an ion forms, it's because it's losing its outer energy level electrons. In the case of sodium, sodium only has 1 outer level electron. Remember, sodium's in that first column, which we said was +1. So if I wrote its electron configuration, what happens is sodium loses that 1 electron, and the electron configuration now is 1s2, 2s2, 2p6. Same thing with calcium. Calcium is in that second column, and I remember I said everything in that second column is +2. So what happens is calcium is going to lose its valence electrons, which is a 4s2, right? Those are my outer electrons. And so its electron configuration for calcium +2 is 1s2, 2s2, 2p6, 3s2, 3p6. So when atoms form ions, it's because they're losing that outermost electron, and that's why everything in the first column is +1 because it only has 1 valence electron, and everything in that second column is +2 because there's only 2. let's look at anions, because right, we have the ones that also then are negative, 3, -2, -1. An anion, remember, is a negatively charged ion, and it gains electrons. So I have this for fluorine. Its electron configuration was 1s2, 2s2, 2p5. So what's going to happen is it's going to fill electrons into this 2p5 till it's full. So the reason why fluorine is -1 is because it's going to gain 1 electron, and when it does that, it fills up this 2p orbital, and it becomes 2p6. So my electron configuration for fluorine -1 is 1s2, 2s2, 2p6. Oxygen, remember, is in the column that's -2, and the reason why oxygen is -2 is because if we wrote its normal electron configuration, it'd be 1s2, 2s2, 2p4, so it only needs 2 electrons to be completely full, that p orbital. And so if it gains 2 electrons, then it has a completely full shell. Things with full shells are happy. So it's 1s2, 2s2, 2p6. All right, that's all I got for you today. See you in class.